What if your AI could use any tool, access any database, and work with any application without custom integrations? And what if every AI model could do that using the exact same protocol? That's the problem MCP solves. In this video, we'll explore what Model Context Protocol is, why it matters, how it works under the hood, and why many people call it the USB-C of AI. Before MCP, every AI model needed custom integrations for every tool. If you have 4 AI models and 5 tools, you end up maintaining 20 separate integrations. Add more models or tools, and complexity explodes exponentially. This integration nightmare slows development, increases maintenance cost, and creates vendor lock-in. MCP changes the architecture completely. Instead of every model talking to every tool directly, everything communicates through a single standardized protocol. Now each AI only needs MCP support and each tool only needs an MCP server. The result is dramatically fewer integrations and much better interoperability. MCP revolves around three core primitives. First, tools. Actions the model can execute, like searching, writing files, or making API calls. Second, resources. Read only context such as documents, databases, or knowledge bases. Third, prompts. Reusable templates that can be shared across systems. Together, these form the foundation of entire protocol. Let's trace a complete MCP request. A user sends a request to the AI model. The model reasons about what it needs and decides whether a tool call is required. The MCP client packages that request using JSON RPC and sends it to an MCP server. The server interacts with external systems, retrieves results, structured responses back. The model then uses those results to generate its final answer. Before any useful work happens, the client and server perform a handshake. First, the client initializes the connection. Next, the server advertises its capabilities and supported protocol version. After compatibility is confirmed, the client discovers available tools, resources, and prompts. Only then does normal operation begin. Think of it as the AI equivalent of devices negotiating before data transfer. MCP supports multiple transport mechanisms. STDIO is ideal for local tools because it's simple and fast. HTTP combined with server-sent events works well for remote cloud deployments. And WebSockets enable real-time bidirectional communication with very low latency. The protocol remains the same, regardless of how messages are transported. This is where MCP becomes extremely powerful. Modern AI agents follow a cycle often called REACT: reason, act, and observe. The model plans its next step, then it executes an MCP tool. It observes the result and then uses that new information to plan again. This loop continues until the objective is completed. MCP is rapidly becoming an industry-wide ecosystem. AI models, IDEs, databases, browsers, productivity apps, and entire platforms can all expose MCP interfaces because everyone speaks the same protocol. New tools become instantly compatible with existing AI systems. That's the network effect driving MCP adoption. Giving AI access to tools sounds powerful, but also risky. That's why security is a major part of MCP. Servers explicitly declare available capabilities. Users can approve or deny actions. Authentication mechanisms control access, and permissions can be restricted at a very granular level. The goal is controlled access, not unrestricted autonomy. At first glance, MCP may look similar to REST APIs, but they are designed for different purposes. REST is built for application-to-application communication. MCP is built specifically for AI-to-tool communication. REST exposes endpoints. MCP exposes capabilities, tools, resources, and prompts in a format optimized for language models. You can think of MCP as an intelligence layer on top of traditional APIs. For enterprises, MCP offers several advantages. Standardized integrations reduce engineering effort. AI systems become easier to maintain. Tools can be swapped without rewriting applications. And organizations can create secure internal MCP servers that expose proprietary systems to AI agents. This is one reason MCP is gaining traction in production environments. Let's summarize everything. MCP is an open standard for connecting AI systems with tools and data. It solves the integration explosion problem. It introduces three primitives: tools, resources, and prompts. It uses a structured client-server architecture built on JSON RPC, and it provides the foundation for many capable AI agents. So that's MCP in a nutshell. A simple idea with potentially massive impact on how AI systems interact with the world. If MCP succeeds, AI tools may become as interoperable as USB devices are today. If you found this breakdown useful, hit like, subscribe for more deep dives into AI systems, agents, LLMs, and ML engineering, and let me know in the comments. Do you think MCP will become the universal standard for AI integration? Thanks for watching, and I'll see you in the next one.